Hello everyone, my name is Abhigya Lamichhane and I will be doing my Teach One presentation on do operations in causal network. Causal inference in statistics, when we talk about causal inference, it is the process of determining the cause and effect relationship between variables. It goes beyond mere correlations to establish whether and how one variable are directly affected by another variable. This is typically done using statistical methods, experiments, or graphical models like Bayesian networks, that is what we'll be doing today. And under the causal inference, do operation is a crucial concept in which uses the interventions often represented by do expressions, which means to isolate the effect of one variable to get the outcome of another. And by manipulating one variable and observing the change in others, researchers can untangle the causal relationship from simple correlations. So for Teach One, I'll be focusing on do operations week 3, question 3, where we will calculate the causal impact of fever on diagnosis of COVID using do operation. The first step is to download Netica, follow the instructions on questions and download the zipped file. There is a .neta file on zipped file, which is called COVID December 2023. And you can open the Neta file using Netica app, which should look like this. As I mentioned before, we'll be looking at this Bayesian model to look at the relationship between fatigue, shivering, loss of taste, and how it is correlated to fever and then COVID-19. So using the do operation in Netica, we're examining the causal impact of fever on the diagnosis of COVID. Based on the provided Excel chart on the question, we are considering 3 other symptoms, which are shivering, loss of taste, and fatigue. Manipulating these variables. So we'll be manipulating either the fever was present, fatigue was present, shivering was present or not, loss of taste is present or not. We'll be manipulating these variables to get the report the symptom of COVID-19. As you can see, the change in probability as we change different symptoms are present along with fever. So when we did what we did on the previous slide, we said fever was present, shivering was present, fatigue was present, and loss of taste was not present. It took us to the outcome where positive probability was 62.7 and negative probability was 37.3. And this a similar example where fever is not present, shivering is present, fatigue is not present, and loss of taste is present. As you can see, the probability of positive COVID test is 49.7 and negative is 50.3. Calculation of causal impact using the formula for the causal effect in terms of pre-intervention probabilities. I got the formula from the book, the provided reading for the week. As we already have the probability of COVID if fever, probability of COVID if no fever, the first step we'll be doing is calculating the weighted probability COVID if fever, which will be multiplication of probability of fever multiplied by probability of change, which will give us probability of COVID if fever. Similarly, we'll do the same thing for if no fever. We'll do the sum of all of them, and the causal impact will be sum of weighted probability of COVID if fever minus sum of weighted probability COVID if no fever, and our causal impact is 0.117. And that is the end of my presentation. Thank you.